Okay, so this is a this is a first order equation, and it's not linear because we have terms like 6x squared, we're multiplying x by dx dt, that sort of thing. So it's a nonlinear equation. And basically for an equation like this, there's two strategies. One is separation of variables, the other is to try to do this as an exact equation. And separation of variables is really just, or separable equations is what I meant. It's just kind of a subset of exact equations. So we're going to try to do this as an exact equation. If it turns out to be one that we can do with separation of variables, the same technique is going to work. Okay. So remember, we call this the function m, we call this the function n, and the idea is we want to know, is there some unknown function f that satisfies the following properties? M is equal to the derivative of f with respect to t, and n is equal to the derivative of f with respect to x. If there is such a function, we have a procedure to find it, and there is such a function if and only if the partial derivative of m with respect to x is equal to the partial derivative of n with respect to t. And just to explain why there's ft here and an x derivative here, this fact is based on the fact that the mixed partial derivatives are equal to each other. So mx is really equal to the derivative of f with respect to t and then taking the x derivative, and nt is going to be the derivative with respect to x and then t. And from Calc 3 we know those two things are equal to each other. So basically if these two things are equal to each other, these two things are equal to each other, and then some theory that you learned either in Calc 3 or that we discussed in this class says that yes, if this equality holds, then the equation is exact. In other words, there is such a function that satisfies this property, and we have a procedure to figure it out, or to define that function. Okay, so let's first determine if this equation is exact. So notice that the derivative of m with respect to x is minus 2t, and the derivative of n with respect to t is also minus 2t, and so yes, it is exact. Okay, so now m is equal to the derivative of f with respect to t. So this means f of tx is equal to the antiderivative of m with respect to t. So this is like a partial antiderivative. Okay, and notice that since we are taking the antiderivative of a two-variable function with respect to one variable, the unknown constant, or the arbitrary constant, is really an unknown function of the other variable. Okay, so now we're going to take the antiderivative of this with respect to t. And so the antiderivative of 3t squared with respect to t is t cubed. The antiderivative of minus 2tx with respect to t is t squared x, and then plus 2t, and we're going to carry down the h of x. Okay, so now we've almost figured out what f is. We just have this unknown function h, and we're going to use the other piece of information, which is the partial derivative of f with respect to x is equal to n, and n is 6x squared minus t squared plus x. Okay, we also know this is f, and so if I take the derivative of that with respect to x, it should equal this right here. It should equal n. So I'm going to take the derivative with respect to x, and you get minus t squared plus h prime of x. Okay, and observe here, okay, that I can solve for h of x, or h prime of x, and I get that h prime of x is equal, so this is an equal sign. This kind of looks like got a little garbled into a minus sign. It looks like it is an equal sign, and I get that h prime of x is equal to 6x squared plus x. Okay, and notice that the t squares cancel out. Okay, so when you're doing this, if you're solving for h prime of x, if you have t stuff, then it means you've done something wrong. Either it's not exact or you've made a mistake at some point. Okay, so now solving for h of x, just taking the antiderivative with respect to x, you get h of x is equal to 2x cubed plus 1/2 x squared plus c. Okay, so what this means, I have my f, I'm just gonna add my h to it. So f of tx is equal to t cubed minus t squared x plus 2t plus, I'm going to add my h, plus 2x cubed plus 1/2 x squared. Okay, and I have a plus c, but let's come up here. Let me just remind you what's really going on here for a second. This left-hand side is equal to the derivative of f with respect to t, and that's equal to 0. So this means f of tx is a constant. So really, what we're writing is f of tx is equal to some constant, okay? And so we're just going to put the constant on the other side of the equal sign like that. If my thing would erase properly, we can move on. Okay. Okay, and so this is the final answer. F of tx is equal to this, and that's equal to some constant. Okay, so that's method 1. Whoops. That's method 1. So notice that we could also have taken the antiderivative. Now on the test, you just have to do it one way. So this, let me write here, is method 1. On the test, you know, this is a multiple choice question, so you do it however you want. This is method 2. Okay, so method 2, instead of taking the antiderivative of f with respect to x, or instead of taking the antiderivative of m with respect to t, we can take the antiderivative of n with respect to x. So n is 6x squared minus t squared plus x. And now if we're taking the antiderivative with respect to x, we need to add an unknown function of t. And so if I take the antiderivative of this with respect to x, the antiderivative of 6x squared with respect to x is 2x cubed. The antiderivative of minus t squared with respect to x is x t squared. The antiderivative of x with respect to x is x squared over 2, and then plus our arbitrary function of t. Now we're going to do something similar. We know that the partial derivative of f with respect to t is equal to m, and we know that m is equal to 3t squared minus 2tx plus 2. And I'm going to take the derivative of this with respect to t, and I'm going to get minus 2tx plus h prime of t. Okay, the minus 2tx's cancel, and you get h prime of t is equal to 3t squared plus 2. And notice here, h prime of t should only be a function of t, so if we add x stuff, it would mean that we've made a mistake. And so now to find h of t, I'm just going to take the antiderivative. H of t is equal to t cubed plus 2t plus c, and now I'm just going to add that to my f, and I've got the general solution is 2x cubed minus xt squared plus x squared over 2 plus h of t, t cubed plus 2t now is going to be equal to some constant. Okay, and so there you have it, 2 different ways to solve the same problem. They're symmetric, so you do whichever way works for you the best.